What's that?
I'm just kidding. They're not easy.
Some of them are, so they're easy. So the thing is, we're going to talk about exponents in general. Then we're going to talk about properties of exponents. And the thing with properties of exponents is we're going to knock them all out in one day. We're going to do them today. Because on their own, they're all pretty straightforward. It's all like, yep, got it, got it, got it. It's when they're all mixed together that it gets tricky. So that'll be Monday, that'll be Tuesday, right? Trying to do more than one at once, knowing which one to do first, right? But first we got to know them. First we got to get good at them. So that's what we're going to do. And there's a lot of opportunities for simple little mistakes that we all make, that I make as well, if we're not careful, if we're not paying attention. So today we're going to try to avoid those and identify those. So speaking of, well, actually, before we even do that, let's focus in on number 6 here. Before we can talk about exponents, we need language to talk about exponents, so we need the words to talk about the exponents. So when I say them, you know what I'm talking about, right? If you forgot them or if you never heard them before. So let's label this thing, right? And let's talk about what each thing does. For instance, that part. So actually, sometimes when I give you these weird formulas, you're like, what is this? These are placeholders. I'll give you an example as well. 4 squared equals 16, right? Whatever. So the 4 or the b, what is that? What do we call that? What part of that exponential expression is that? Yeah,
Base.
that is the base. Very good. And the base, what does it do? What do we do with it? Like, for instance, with the 4, what happens with it? Yeah.
You multiply it by itself however many times.
So it's the thing but just the base, right, is the thing you multiply, right? It's the thing that's multiplying, right? The thing you multiply by. Okay, great, awesome. And then this piece, so the 2 or the e, that's the exponent, right? Now, this is a little trickier to define because the words we use for this kind of get confusing. They make sense to some people, they make sense to not other people. So I'm going to maybe add a piece unless you have it. Go ahead.
It's the number of times you multiply the
Okay.
base.
Okay, so it's the number of times you multiply the base. So I multiply it by 4 2 times?
Yeah.
Okay, so 4 times 4 times 4? Because that's, you start with 4, and then I multiply by 4, and then I multiply by 4 again?
No.
2 times.
So it's just 4 times 4.
Yeah.
Isn't that just one multiplication?
I mean, yeah, but
So this is why it's tricky to define, right? We want a way to define this that nobody can get confused by. Yeah?
The number of bases you're multiplying together.
Okay. Let's keep going.
The number of times you're multiplying the number by itself.
Okay. The moment of time you multiply the number by itself, so 4, I still would think maybe some students would multiply the base by itself 2 times, which would be 4 times 4 times 4. It's closer. But, okay, the reason I'm going through this is that's the definition we've been given, Algebra 1, right? I'm adding a piece, ready? And I'm hoping that this piece helps in a couple different ways, right? So, what we're going to say is it's the number of times we multiply one by the base. Anybody know what I mean by that? So think about this. I'm multiplying.
1 time, so 4 times.
No, the number 1, the value 1. Go ahead.
Would it be kind of like no, I was going to say something about it being by the power of 1, but that would make no sense.
So Does multiplying by 1 change anything? No. So I'm going to put a little imaginary 1 times forward to the second out front. Always imagine that there's a 1 times out there. Because now, if I can use this language, I can say, okay, it's 1 times 4 2 times. 1 times 4 times 4. Now the exponent adds up, and I get to 16. Okay? Nobody can be confused by that. It's just 1 times 4 2 times. You can just read it going across. Right? You always imagine a 1 out front. What's that?
4 2 times.
But that doesn't tell me everything. I need a definition that works for everybody. 4 2 times doesn't tell me what to do with the 2, like 2 times, and we talked about how multiplying by 2 times doesn't really work. The other thing is when we get to our properties, this is going to make a couple of our properties a lot clearer if you imagine a 1 out front. Yeah?
When we're dealing with exponents, will we ever do anything other than multiply with them?
Yes. If you had 4 to the 1/2.
Oh, God.
Yeah. So that's why we got to clear this out. Okay, so 1 times 4, 2 times. Okay, and then this is just our answer, which is the product of our multiplication. Okay, so just stick with me on that new definition. You'll see it later in the lesson, and you'll be like, oh, that's why he made us do that. So this is the product of the multiplication. Whoa. Okay, so now when I use these words, we know what we're doing. Okay? All right, so let's go to this example. All right, negative parentheses 3 squared. Anybody think they know? What I'll do is I'll ask for your answer, and then I'll expand it out to prove it. Go ahead. What do you think, Hannah? -9. Okay? What mistake do you think, what other answer do you think people might come up with? Yeah. 9. Okay. If you're looking at a problem like this and you're not sure, you're like, is this -9 or 9? There's one thing you could always do. And you're going to hear me say this a lot. When in doubt, write it out, meaning expand it out. So what is this? So let's just get rid of the exponent by expanding this, right? So anytime we see an exponent, we do what the exponent is saying. So 3 squared is actually 3 times 3. Okay? We've gotten rid of the exponent. Now we're in an order of operation situation. What is 3 times 3? 9. We do that first because it's in parentheses. So I have -9. Does that make sense? Okay. Now, same thing down here. I have -3 squared. So it must also be -9? No. What is it? 9. And by the way, these are all problems that I made because these are the mistakes I see in this unit. Okay? And you might be like, well, I would never make that mistake. In the middle of a problem, when you're doing all this other stuff, you stop thinking and you get on a roll, right? So we need to install stuff in our brain to stop us in our tracks. Now, if I expanded this out, here's the word. What is the base? It's -3. It's the whole thing, right? So what is being squared? -3. So what is getting multiplied by itself by 1? -3 times -3, negative times a negative is a positive, and that gives me a +9. Make sense? What about this? Instead of 3, I have -x. Now how do I do that? What does that become?
That's just -1 with the exponent, well, not with the x, with the variable x.
X squared.
Positive x squared?
Yeah, it would be positive x squared.
Okay. Let's test it out. What is being raised to the second power? What is the base? -x. So if I expanded that out, that's -x times -x. -1x times -1x. -1 times -1 is positive. And then x times x is x squared. So that is indeed positive x squared. Does that make sense? All right, -x to the third. Oh, sweet. So it looks like the exponent gets rid of the negative. So this must be positive x to the third. Anybody think? Yeah, what do you think?
It multiplies it 3 times, so instead of canceling it out,
it back.
Correct. So, a couple things here. This is indeed negative x to the third. Okay? A couple ways to understand and remember this. If I have negative x times negative x times negative x, just like we did up here, left to right, negative times a negative is a? Can you put your phone away, please? Positive. Negative times a negative is a positive, and then that positive times a negative is a negative. So I end up with negative x to the third. Okay, that's great. You can expand it out. What if I gave you parentheses, negative x to the 17? Do you have to expand that out to figure out where it falls?
No,
Why not?
because it's an odd.
Because it's an odd number. And we know if you had pairs, like any pair would cancel to become positive, and if you have one more after that, one more, right? Any odd number would give you one more at the end, that would turn it negative. So any odd number, exponent, with a negative on the inside stays negative. Any even number with a negative on the inside becomes positive. There you go. You don't have to do this again, right? So, okay, negative x squared, so that must become positive. What do we think? Is this, what's that? Yeah.
The negative's technically on the outside, so that means that first you'd multiply x times itself for x squared, and then you'd multiply the negative in.
Good. You have anything to add?
I was going to add on the invisible one rule.
Absolutely. This is exactly where it makes things clearer, right? So you could think of this as negative 1 times x squared. Now it's really clear that that negative has nothing to do with the exponent, right? It's completely separate. That exponent's over here, the negative 1's over here. It's being applied later. So this stays negative x squared, okay? Feeling good? Okay, so today we're going to roll through these properties pretty quickly, right? Hopefully you've seen them before, but if you haven't, that's fine. You could learn them today, for sure. Everybody in this room. This unit is kind of a new opportunity to lock in because the last couple units have kept building on each other. This unit kind of takes a turn, goes in a new direction, right? So that's good if you feel like you've been waiting for an opportunity to get back in because you don't have to rely so much on the stuff we've previously done. Okay? All right, so go to your green paper. And we're going to add some notes. Okay, so I'm going to go through these properties. For each of these properties, I'm going to give you a formal definition, and then examples, and then you do some problems, and then we move on. Make sense? Okay. The formal definition is always going to look like this. I'm going to use these like A, M, and N just as placeholders, and then I'll show you it with numbers. So for the product property, product means to multiply. So that's if you have, I forgot. For any of these properties, write this at the top. For all properties, you need common, which means the same, base. You need common bases, right? So they have to be the same base or you can't apply the property. Okay? So a to the m times a to the n. Same base. So anybody remember what you do? You add. This becomes a to the m plus n. And I know some people like the property. Some people are like, can you just show me some numbers? So I'll do that. For instance, if you had 5 squared times 5 to the 4th, right? Same base. I wouldn't go 5 times 5, make it 25, and then I keep my base, and I add the exponent. So what would that end up being? 5 to the 6th. I'm going to prove it. Ready? What is 5 squared? Well, that's 5 times 5. What is 5 to the 4th? That's 5 times 5 times 5 times 5. Right? Here's my squared. Here's my to the 4th. If I wanted to roll that back up and do an exponent, it would be how many 5s? 6 of them. Okay? You have to prove it every time. It's helpful to see it, though, right? So you can just add. 2 plus 4 gives you that 6. Okay, you do these problems. Go ahead. If I have x squared, x to the fifth, same base, so I just add the exponents, and this is x to the 7th, right? So if you just know these, you can go so quick. Here, I have 3 to the 4th times 3 to the 6th. It is 3 to the 10th. What mistake do we want to look out for here that sometimes maybe happens? Somebody would say like 9, right? And then do the exponents. Like, leave your bases alone. Keep your bases, apply your property. So this is not 9, it's 3, 3, 3, 3, and then 6 more 3s, which becomes 3 to the 9th, or 3 to the 10th, right? Okay, this one. What do we think? 20x to the 8, right? What do you think the mistake that people might make here is? Yeah.
You have to multiply. You have to do 20 to the power of 8.
Right. And this is an example of like when you're in the middle of a problem and you're just going, you're not thinking, you're like, oh, when I have these, I add, and you add everything. So you just go 4 plus 5, right? But that's forgetting what's happening here, right? What's happening? Well, this is really, well, actually, what is the 4 and the 5 here? What is that? It's a what? It's a coefficient, and a coefficient is a number that's being multiplied by a variable, right? It's 4 in front of the x, that's 4 times x, right? So there's multiplication happening here, here, and here. So we can expand this whole thing and say 4 times x times x times x times x times x times 5 times x times x times x, right?
And then combine the like terms.
Everything's multiplying, right? So you multiply what you can. 4 times 5 is 20. How many x's do you have? 8, right? In all of these properties, if you want to write this down, you can. Do not apply the rule to the coefficients. The coefficients are normal numbers. Leave them to do their normal things. Make sense? All right. Quotient property. Very similar. Quotient is when we divide. So this is about dividing. I have a to the m over a to the n, which is a to the m minus n. So we subtract. For example, you might have 7 to the 5th over 7 to the 3rd, right? So you would say, okay, that's same base. So I subtract, I get 7 to the 2nd. And here we'll prove it. Ready? 7 times 7 times 7 times 7 times 7 over 7 times 7 times 7. What happens when you have a number divided by itself? It cancels because that's 1. 7 over 7 is 1. So that's 1, that's 1, that's 1. And what am I left with? 2 7s being multiplied, which is 7 squared, right? So it makes sense every time you expand it out if you ever need to, okay? Go ahead and do these problems. So if I have x to the 5th over x squared, I know I have the same base, and I just subtract. So that's x to the 3rd. If I have 5 to the 8th over 5 to the 4th, same base. Always keep your base, right? Don't divide the base. Don't give me 1. It's still 5. And then 8 minus 4 is 4. All right, just be careful. Leave the base alone. Keep the base. Okay, how about this one? Anybody got an answer? 2/8 x to the 8th. Anybody else? 4x to the 8th. Anybody else? Go ahead.
1/4 x to the 8th.
1. We just hit a lot of stuff there, right? A lot of things that people do. You can reduce, you got to reduce, right? A lot of people know that 2 goes into 8, so they just divide 8 by 2. But that's not what's happening here. 2 is dividing by 8, right? And then you have another thing we haven't even mentioned yet. How do we get x to the 8 if I got 9 and I got nothing down there?
That's 1.
You have a 1. And this is something I really recommend. If these things trip you up, add 1s when you see nothing. Because it reminds me, that's not 9 minus 0. That's 9 minus 1, right? So if I expanded this out, well, I got 2. Oh boy, here we go. X, 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 X over 8X. Right? So they cancel. And then 2 over 8 can reduce. They both divide by 2. That's 1 over 4. So I end up with x to the 8th over 4. Okay? Which is more, I guess, simplified than 1/4 x to the 8th. But that's fine. Either is fine. If you understand it, that's good. Okay, next property. Kind of my favorite. Because it's both simple and complicated at the same time. Right? It's one of those things that maybe you know, but you couldn't totally explain. Or maybe you can. We'll see. Okay. Anybody know what 5 to the 0 is? Or, for that matter, x to the 0? Or, I don't know, 100 to the 0 is? What all of these things is?
Whatever the number is.
I'm hearing a couple different answers.
If we had x to the 0 and it disappeared.
Go ahead. Not 0. Hannah? It's 1.
Oh, that's right.
This is why I changed the definition. Think about it this way. If there's a 1 out here, and we said it's 1 times the base, the number of times of the exponent, right? So this is 1 times 5. How many times? 0 times. So no times, right? Don't multiply by 5. Just 1. Okay? This is 1 times 5. No times. Okay? Now, that makes sense for a lot of people. This other thing makes sense for everybody else, and then we get everybody. All right? So I'm going to prove this to you another way. Ready? Okay, let's say I'm doing some work for my teacher, and they ask me for 5 squared. What's 5 squared? 25. And then my teacher says, well, actually, I need you to give me 5 to the 3rd, but I forgot what it is. But I do know 5 squared. So how do I get to 5 to the 3rd? If I have 5 squared and I just want to bump it up to 5 to the 3rd, I just multiply by 5. So I'll go times 5. 25 times 5, that gives me my 5 to the 3rd. And then she said, okay, go backwards. What's 5 to the 1? Well, if I'm going backwards, I'm not going to multiply. I'm going to divide by 5. What's 25 divided by 5? 5, right? So that must be what 5 to the 1 is, right? And she says, keep going. So now I'm at 5 to the 0. And I divide by 5. And what is 5 divided by 5? 1. And that will happen anytime you have a 0. It's kind of nice because it just goes away, kind of, right? If you're multiplying by something to the 0, you're really multiplying by 1. Okay? Try those problems. It could be a million to the 0. It's 1. It could be a crazy thing inside parentheses with all the stuff you need to do, but there's a 0 on the outside. You're done. It's 1. Okay, I'm going to write up the answers here, and then we'll talk about the ones we need to talk about. This one is 6x squared. This one is 3. And this one is 1/2. Any questions? Mm-hmm. What's up?
I figured this out when you helped me. But when I tried to separate the two, I did 6 by itself, x by itself, and then y by itself. And because y...
So you did 6 times x squared times y to the 0.
Yeah.
Okay? And what is y to the 0?
1.
1. So this is like multiplying by 1.
1, which is why I thought, since it's the same type of, I thought we were supposed to do something like terms. And so that's why
Well, it's multiplying, so that's why we wouldn't add those, right? It's 6 times 1. This one, same deal. You have 3 times x to the 0, And we now know anything to the 0 is 1. 3 times 1 is just 3. This one, well, our quotient property says this would be x to the 3 minus 3, which is x to the 0. You also could think, well, anything over itself cancels. 5 over 10 is 1/2. All right, makes sense? A couple more, and then we're done. All right. Power to a power property. Okay. Power, by the way, is another way to talk about exponent, to the second power, to the third power, to the fourth power, right? So if you have a to the m, and then that is being raised again to the n, that is a to the m times n. Okay, let's look at some examples. If you have z squared to the third, well, this tells me to multiply, so that would be z to the 6. Let's prove it by expanding it, right? What's the base there? What's being raised to the third?
Z squared.
Z squared. That's the piece that's being raised to the third. That's what needs to be multiplied by 1 3 times. So I would say z squared times z squared times z squared, right? Well, now we have our product rule. Same base, we add the exponents. So that's z, I'm going to make my z's look less like 2's. Z to the 2 plus 2 plus 2, or z to the 6. And that 2 plus 2 plus 2 is just 2 times 3, which was our original 2 exponents, so you just multiply them out. Questions? All right, do those problems? All right, what would you like to talk about?
Wouldn't you have to break apart the x and a y?
Sure, we can do that. Want to talk about the last one?
Yes, please.
Okay, so let's look at this last one. Now, what do we say is, if there's not an exponent, is actually there? A 1. And if it's helpful, always add it. Okay, so now I have x to the 1 times y to the third, all of being raised to the 6, right? And our power to a power says multiply. So that's x to the 1 times 6 times y to the 3 times 6. Well, what is 1 times 6? 6. 3 times 6 is 18. Okay? So you apply the exponent to everything on the inside, right? Just like here. What doesn't have an exponent on it? 3. So if it helps, that's 3 to the 1, right? So this is 3 to the 1 times 2 times x to the 5 times 2. Well, that's 3 squared, right? 3 squared is 9. Make sense? All right. One more property. Ready? And we're going to do this, we're going to make sense of this a very similar way that we did 0, to the 0, right? If I told you to apply the quotient property right now, what would you do? The quotient property is when we divide, so yes, it would be 4 to the 3 minus 5, which is 4 to the negative 2. So the question is, what do we do with that? There's a rule. We'll talk about it. But let's explore it first. So let's say I have 4 to the 1, which we know is 4. And then I have 4 squared, which I know is 16, and 4 to the third, which I know is 64. Okay, we talked about this already, but to go this way, I would do what? Times 4 every time, right? So to go this way, right, I would divide by 4. So that, we talked about this already, but that 4 to the 0, 4 divided by 4 is 1, right? But now we want to keep going to 4 to the negative 1 and 4 to the negative 2. So I divide by 4 again. What is 1 divided by 4? 1/4, right? We're going to leave it as a fraction. What'd you say? Say again?
You have to say -4 or 1/4.
Well, this is this. So this is what we prefer. We don't really like negative exponents, so we can get rid of them. So what if I did it again? It's 1/16. Okay? Now, how do I avoid having to make this table every time? Well, what's another way to write 1/16 by putting a 4 back in it? 1 over what? What's another way to write 16 but with a 4? 4 squared. What's another way to write this then? 1 over 4 to the 1. Does anybody see it yet? What do we do when we have a negative exponent?
We just put 1. Oh, we put 1 upstairs and
Negative downstairs.
Very good. That's what I'd love to tell my algebra algebra 1 kids. They get a kick out of that. If you're feeling negative, right? Say you're in your house. You're in a bad mood. Sometimes a change of scenery helps. Maybe your little brother is bothering you upstairs. You go downstairs, you start feeling a little more positive. Then he comes downstairs, he starts bothering you again, you get negative, and you go upstairs and you feel more positive. Change your floors and you'll become positive. Okay? And that's the only thing that changes. So, this is on the top floor just by default, right? Everything starts on the top floor, so it goes to the bottom floor and it gets a little positive, right? But what if I started on the bottom floor? Go to the top floor and I become positive. Now, one more thing. Anytime you leave a floor alone, you put a 1. Don't just leave it blank, right? You can't just leave a top of... What's up?
But then couldn't it just be 2/3? Or 2 to the 3rd?
Yes, exactly. So I was showing the floor movement, but then if you have 2 to the 3rd over 1, you'd say that's just 2 to the 3rd, right? So switch your floors and you become positive. Make sense? Okay, go ahead and do those problems. Oh, I didn't really write it. I'll write the property too. A to the negative n equals 1 over a to the n. And 1 over a to the negative n is the same as a to the n. And if you get a question, it's going to say, hey, don't leave any negative exponents in your answer. So if you end up with a negative exponent after your work, you're going to have to move it in order to get your final answer. Okay, so if I have x to the negative 5th, by default, it's on the top floor, and it's feeling negative. So it's going to go down. So it's 1 over x to the 5th. It becomes positive. Right? This one's on the bottom floor, so I'm going to move it up, and it becomes positive. Y squared over 1, that's just y squared. What's my answer here? 3 over x to the 5th. Once again, the only thing being raised to a negative exponent right now is x. 3 is being raised to the 1. Leave it alone. It's feeling positive already. It doesn't need to move. Okay? Don't ruin its day. All right. And then finally, what do we have here?
1 over x to the 6th.
Ooh. It's 1 over x to the 5th. So there's a little preview of where we're going next, right? There are 3 properties happening here at once.
Never mind.
So hold on, let me get this thought out here. There are 3 properties happening here at once, and this is what we're going to have to start doing. All the properties in the same problem, okay? So a little preview is if you have stuff on the top and you have stuff on the bottom, figure out the top and the bottom, then worry about going up and down, right? So if you have x, well, that's to the 1, times x squared. On the top, I'll have x to the 3rd. X to the 3rd times x to the 5th, x to the 8th. Okay, now I have my quotient property. 3 minus 8 is negative 5. X to the negative 5, that's feeling negative, so it's going to move down, right? And I just applied 3 properties in one problem, right? And that's where we're going, and they're going to get a little crazier than that. Question? Yes, you could have seen that x, and x squared is x to the third over x to the third. Cancels, that leaves you with 1 over x to the fifth. There's a lot of ways to solve these problems. People are going to do them different ways. Yeah? Okay.
If you get x to the fifth, you can't make it